It's 2022 and women in science are still less likely than their male peers to be hired and promoted. Women are less likely to be mentored by eminent faculty, they publish in less prestigious journals, have fewer collaborators, are underrepresented among journal reviewers and editors, and their papers receive fewer citations. How is this happening? USC's Information Sciences Institute, ISI, principal scientist Kristina Lerman and her team used AI to look for answers to this question. The resulting paper has been published in the prestigious, peer-reviewed, multi-disciplinary science journal Proceedings of the National Academy of Sciences, PNAS, on September 26, 2022. As a woman in science herself, Lerman knows the world she works in, but even she was shocked by statistics she recently learned. Only 2% of Nobel Prize winners in physics have been women. Until a few years ago that was 1%. And those numbers are similar across many scientific fields. We were curious about this discrepancy. Right data, right time. Lerman had the right dataset for the problem. Since 2019, she and her team had been working on a large project that used AI to predict the reproducibility of research papers. They published the paper, Assessing Scientific Research Papers with Knowledge Graphs, at ACM SIGIR 22, the Association for Computing Machinery's Special Interest Group on Information Retrieval, in July 2022, describing their novel method and promising findings. To do this reproducibility research, Lerman's team gathered a huge amount of data on academic papers. The team looked at the shapes or structures that arose in the knowledge graph. They wondered if there was some kind of natural phenomenon causing the different structures in the citation networks. Additionally, they wanted to make sure that the data used in their reproducibility predictions was not being impacted by biases in the data. First, as background, in order to understand their paper, an author will cite other papers that give the background information needed. Second, to explain a method. If an author used a method that's similar, a version of, or comparable to a method from another paper, they will cite the paper that explains that method. And third, results. An author will explain their results, but might cite other papers that studied that same thing but got different results. Gleaning information from citations. Trying to study the citation network for every researcher out there is really hard. So why don't we pick the cream of the crop? Said Pujara. The team looked at scientists elected to the U.S. National Academy of Sciences, NAS, one of the oldest and most prominent professional science organizations. New members of NAS are elected by current members based on a distinguished record of scientific achievement, meaning, in theory, they've all reached the same echelon of recognition. Women's networks were much more tightly clustered, indicating that a female scientist must be more socially embedded and have a stronger support network than her male counterparts. The differences were systemic enough to allow the gender of the member to be accurately classified based on their citation network alone. This was pretty shocking and disappointing to us. As a control study, the team also looked at the covariate of prestige. NAS members affiliated with less prestigious institutions are a minority in NAS, similar to women. They did not observe any disparities due to the prestige of a member's institutional affiliation. Conclusion. Based on a scientist's citation network alone, gender can accurately be determined, but the prestige of the university that scientist is affiliated with cannot. This suggests that gender continues to influence career success in science, according to the ISI team. How to stop being so short-sighted? Why is this happening? So we don't actually know the answer to that. What we know is that there's a difference. The real question is, how can we change it? How can we make science a less hostile climate for women, remove the barriers to opportunities for women, and create an environment that allows women to rise to the top of their fields? Additionally, it could be used as a way for policymakers to understand if programs aiming to improve gender equity in science are working. Finally, and importantly, we can learn from those differences in the citation structures between men and women. For a woman to be recognized, she has to be well embedded and have a strong support network, Lerman said. Mentoring young women and telling them they really have to build those networks of social support, and be very intentional about them, seems to be one way to change the shape of these structures, and the shape of science. Breaking the glass ceiling in science by looking at citations. Using artificial intelligence to study gender disparities in science. Science Daily. https://ift. tt. zdtodi6. Accessed October 4, 2022. Thanks for watching. Please subscribe my channel for more videos.